I want to talk to you about measuring web performance. I work for a company which is called Neuland, and we are based in Bremen, and we develop e-commerce solutions. So we work together with big companies like Douglas, Otto, Ruby, whatever, and we build e-commerce solutions for them, with them. And in e-commerce, in the web in general, performance is very crucial, but in e-commerce it's even more crucial because early on people discovered that there is a correlation between fast loading sites and users that stick on your page longer on your page and buy stuff, so making money. Yes, this is the why part. I think I don't have to explain more about the why we should measure, because measuring is the thing we need to improve. The more important thing is the what to measure. So there are different things people were measuring over time, over the last years on web pages. The most classical thing is resource-related things. So you look at what your browser is loading, and then you can determine your page rate, for example. You just go to the log and count every asset, the kilobytes of every asset, and then you can calculate a sum of all assets that are needed to display one page, for example. This is important for if you have a slow connection, for example, when you don't live in urban areas, when you are on a mobile phone, when you have a metered contract, for example, and you don't want to misuse the user's data with images that were never viewed, for example. Page rate is an important thing. There are optimization techniques like reducing unneeded things, minifying, gzipping stuff. I think everyone here knows how to do this. Number of requests is the other popular thing that was very important, very prominent over the last years. In the last few years, the importance of number of requests reduced because HTTP2 was introduced. So techniques like spriting, bundling, distributing your assets across multiple domains, so the browser would, and circumventing the 8 parallel download limits per domain. These were all techniques that were employed in the last years, but HTTP2 solves most of these issues and provides you one connection which you use to multiplex and download in parallel the things that are needed the most. Cacheability is the thing when the user opens one page, and when he clicks to another page, he doesn't need to download everything again. Things that are stable can be cached by the browser, all pretty basic stuff. Things that are more interesting are timing-based metrics. The classical one is time to first byte. So this is the time the server needs to respond to the browser with the first parts of the HTML. If someone clicks on the link, the browser waits until it receives the HTML from the server, and the response time from the server is the time to first byte. You can optimize the time to first byte by employing something like streaming templates, which I haven't come across very often. It's talked about a lot, but I think too few frameworks of web applications really do it. It's a technique where when first part of your template is executed, you are free to push it to the browser without waiting for the whole page to be generated, for example. Then we have the load time. The load time is a little bit different or dubious. We have multiple things that qualify as load time. We have the DOM content loaded. This is the time the browser, the point in time where the browser has read through your complete document. So every blocking request in your site was executed, and the browser has finished reading your complete HTML. This is a DOM content complete. When you're using jQuery, it's called document ready, for example. And then there's the load time. This is the time when the browser thinks, okay, everything related to the first view of this page is done now, and this includes third-party codes, tracking, big images that are not in the viewport, for example, and the load time is, most of the time, it's pretty huge value because things are loaded that are not non-critical, and the DOM content loaded is a time which is a little bit too far, and the reality, the point you want to know is one time point in between. It's the point where your page is usable or your page works for the use case the user came to your site. There's a web API, a new web API, which is called a custom metrics. You can just call window performance.mark and provide a string. And what the browser does, it writes time code in the window, in the performance object, and you can query your time codes with an API. So you have I'm not sure if you can read it. You can call get entries by name, for example, and pull out a specific time marker, and then you get the time from the start time, so the time the user started the navigation, to the time your marker fired, for example. More interesting are visual markers. This is time to first paint. As you can see, time to first paint is the time the browser needed to draw the first pixel on the page. A few browsers, Microsoft browsers, support this as an API natively. Most browsers don't provide a special API for it, but there are tools, but I will come to the tools later. What you see in this example is this is not really helpful. It's helpful so that the user knows, okay, something has happened, the site is not broken, something more might come. But a more useful metric is the time to first meaningful paint. This is the time it takes to display the primary content of the page. So for a product list page, for example, it would be the first images and the product text, I would say. But it is kind of a soft metric because it depends on your use case. Maybe there's a big teaser at the top, and this is not needed for in this example, you see it, there is a teaser, and I personally would define this as non-critical content. The site is usable without this teaser. There's a discussion on how to standardize or how to automatically detect this first meaningful paint metric. There's a Google Doc with different strategies on when to automatically determine that this page might be meaningfully painted. Another metric that goes a little bit further is time to visually complete. This is quite easy to measure if you can observe the browser rendering the page. So we have to capture some kind of video, for example, with the explicit viewport. And this is the time where, after this point in time, no visual change will occur in the viewport. So the viewport is fully rendered. Maybe things at the bottom of the page are still loading, but for the user who doesn't see it, maybe he sees a spinner, but this page looks like ready to interact with. So it's a good thing. Then there's a more abstract metric, which is called speed index. The speed index takes the two metrics we've seen before into account. I'm sorry, I can't run over without losing the audio, but at the bottom left corner, you see the spike where the lines go up. At the bottom line, you see seconds over time, so far left, 12 seconds, and the height of the graph shows how visually complete a page is. So the blue page started rendering about 300 milliseconds, for example. The red one did as well, but the blue one made a far higher jump, so it went to 93% in under a second, whereas the red line keeps moving under 20%, and both finish at the same point in time. So if you would look at the first paint measurement and you would look at the visually complete measurements, both websites would have same scores, but it's obvious that the blue one performs far better because it gets to high percentage or more visual picture very fast. And the speed index measures the left upper area of this line. So it's like an integral, but the other way around a little bit. yes, so you see the blue area is quite small, the red area is quite big, and big is not so good, so lower is better, and you want to be the left one. Okay, now on how to measure. One or two things before. A good thing to do initial measurement of your pages just using your browser. Browsers have gotten quite powerful developer tools over the years. Chrome and Firefox have built a network throttling, for example. In Firefox, it's a little bit hidden. It's in responsive design mode, but if you know where responsive design mode is, then you can degrade your connection and see how your site loads and performs under low or bad network conditions. And if you're using a Mac, there's a very cool tool which is called Network Link Conditioner, which downgrades the network connection for your complete computer. This is not cool if you're doing video conferencing in, you will notice. A cool feature Chrome introduced last year is low-end device mode. So one thing is the networking connection, but as we handle big frameworks using a lot of JavaScript right now, it's important to keep in mind that not all devices that interact with your page are top-of-the-line MacBook Pros you use to develop the site, and this mode sets your browser or makes your browser emulate that it only has a fifth, or you can specify the number, of the CPU power your own device has. And when you switch on this mode and use your site, you see which parts of your page are JavaScript heavy or rendering heavy or animation heavy or whatever, and how you can get a feel how they react. So now I have a list of 5 metric tools which you can do structured measurements of the metrics we saw before with. The first one's pretty old. I think most of them have heard the name, you have heard the name Yahoo Wiselow. It's one of the first tools who made a holistic approach to scoring your website performance. So they go through network-based best practices and look if every request has caching headers and is compressed and whatever, and they give you a score. I'm not quite sure if people still use Yahoo Wiselow, but it's one of the first tools. That's why I've included it in the list here. The predecessor, no, the following thing of Yahoo Wiselow was Google PageSpeed. So Google took on the same concept, so providing a score between 0 and 100 and testing best practices stuff, but they went a little bit further. So they also did analyze how the rendering process looked. So they looked through your HTML and saw, okay, you have 20 CSS files in the top of your page that are all blocking, and these are bad things, and they give you recommendation based on the browser behavior and how browsers work. The PageSpeed project was open source at first, and then it got renamed to Google PageSpeed Insights. It got a Google Web Service, which you need API keys to whatever. The rules behind Google PageSpeed aren't transparent. They change over time, and for many rules, you notice that it was built in a pre-responsive web design age, and it has very aggressive mobile rules. For some examples, they advocate inlining styles, which is good if you just delivering a landing page, but if your page consists of multiple pages, and it's common that users don't only use one page of your page. I think from my perspective, it encourages over-optimization. But it's a critical value because Google uses it to rank their search results, so you can't ignore this value. You shouldn't ignore this value. You can, if you want. Yes, this is the father of the speed index. It's a tool called Web Page Test, and it's really, really ugly, and it's also not really usable. So but you should learn how to use it because it's a good tool. It's in the thing. It measures the values are solid, the results are solid, they are reproducible. The web page test project consists of two parts. You have the user interface where you can start tests with, and you can specify you want this browser from this country with this network condition, opening this page, and then give me a video of how this page renders, do 3 runs, give me an average, compare it with another thing. It's really, really powerful. It's backed by a lot of performance-related companies who provide server infrastructure all around the world. Yes, but if you try to do self-hosting, I tried it. The front end can be done with Docker. The back end, the test runners who do video have to be done with a Windows VM with hacked graphics. It's not pretty. Don't. But use the webpagetest.org hosted instance. Another cool thing here is that all test results are visible online. So if you made a test, or if you have a hypothesis, maybe if we implement font loading, this page will, we will get a higher page index, or the fonts will earlier start to render. You can do measurement, implement your feature, do another measurement, and then compare these measurements to each other. And yeah, you have a common view on the topic, on the problem, and you can discuss this with a link with multiple persons. This is quite powerful. A more modern version of web page test, at least as I think of it, is sitespeed.io. It started out as a quite small project, but they were implementing many of the features that made web page test unique. These features are now also integrated in sitespeed.io. This is completely Docker-based. All metrics can be measured on Linux systems, so they use Firefox or Chrome in Docker images. They also do the video recording, visual metrics. They have a modular plugin system. They also have accessibility rules, and it's quite powerful. It's easy to integrate this one into your CI, into your Jenkins or whatever process. You can export metrics to things like Graphite and view them in Grafana and whatever. It is pretty young, so I came across a few bugs while testing different sites. The videos you saw before were all taken with sitespeed.io. It's pretty easy if you have a system where you have Docker running even on your Mac. You have one command line call, and it does a test. It generates the HTML page. It puts a video next to it. It gives you recommendations. It's quite powerful and has a good community. Last one. Google Lighthouse. This is quite new. I'm not quite sure when Google started this project. It comes with this Google initiative to promote progressive web apps. So what Lighthouse does is many things that Google PageSpeed already did, but for the first, it works as a Chrome extension. It also works from the command line. So there is an npm package you can install on your machine, which provides this view you are just seeing here. As you can see, they have a perceptual speed index, first meaningful paint, many of the metrics we just saw before. They're also measuring if your site uses progressive enhancement, for example. So they open up your page without JavaScript and with JavaScript, and they look what features are, which features work without JavaScript, for example. They provide a metric called estimated input latencies. So they are trying to guess what the reaction time is if a user clicks on some element of your page, if this takes a second, or if you're able to give the user feedback in under 100 milliseconds, for example. Okay, but the most important thing is all tools we saw before are lab tools. You specify a test case, and then you test this test case, you sort of the network conditions and browser and whatever against one page or against multiple pages. But the most important thing is, how do users experience your sites? And yes, this one is called real user monitoring. It's nothing new. Most vendors of performance monitoring software today already provide some kind of JavaScript snippet you can stick in your page, and then they measure performance from within your browser. The big advantage of this is that A, you're measuring your real users. Many of the hypotheses you have, like, yeah, my users all have slow connections, or no, there are no users with slow connections, and maybe browser distribution you can estimate from your tracking systems, but doing measurements on the real users and in the real situations is far more powerful, because it weights the values it measures by the users who use your site. For a long time, you had to do multiple things to do real user monitoring in the browser. You had to execute a script right on the start a timer, write a timestamp, and then have scripts or indicators all over the page, all over your place. With modern browsers, there are a lot of APIs, performance-related APIs. We saw the custom timing API before, where you have a structured way of asynchronously accessing the performance data of your site. So your measurement script doesn't have to be present at the start of the page. It's okay if your measurement script comes in 10 seconds later, because it has access to the data the browser collected during its run. So you have the navigation timing API, where you can see timestamps of your page from navigation start, so the user clicks on a link, wants to go to your page, to the end of the load event, but you have many timings in between. So you know how long the TCP did, how long the DNS resolution took, and so on. This is on page level, but in modern browsers, you also get this on resource level. So you have a JavaScript API, you can call performance get entries by type and grab all resources that were used rendering this page. So you have access to everything you see in the network tab of your browser through JavaScript. And you can loop through there and look for external scripts, for example, and look, did external scripts load longer? Which scripts, which assets took more than 1 second, for example? You can do fancy stuff in there. There's another Google project which is called RAM Speed Index. I've talked about Speed Index before. It usually is based on recording a video of how your page is loading in the browser. And you can't do this with JavaScript. You don't have access to the screen. You can't, you don't get this data of how your page is painting. But this RAM Speed Index, they implement a heuristic where they look into the rendered viewport and look, what assets do I need to render this viewport? I need this image I'm seeing, I need the icon for the company logo, I need the CSS for all elements that are in there, and they look backwards, so first they identify all visible things, and second, they go through the network API we saw here, and looked when did these requests finished, and then trying to reverse calculate this line we saw before. And this is a small, it's not a huge blob of code. You can click the link, and I think it's just a gist. No, it's not a gist, it's a project, but it's pretty easy to take this code, copy it into your console, and then run RAM Speed Index, and you get a score. And this score is not that different from the score the video approach takes. It's not perfect, it's an experimental project, but it's pretty cool. Then there's an open source project called Boomerang.js. This is a JavaScript project especially for tracking RAM data or collecting RAM data. It's a little bit older, so yes, it also supports the APIs we saw before, but it also has much code for the things you did it before, so starting timers, setting timers, whatever, handling iframes, all kinds of stuff. It's quite powerful, but it's not that easy to get into. But there is a very great, I think it's a 3-hour video where 2 of the developers who developed the Boomerang.js and also work for a performance company called Sosta talk about this kind of stuff. They talk about how to measure performance inside of a browser. If you want to get deeper into this topic, take 3 hours or view it on higher speed or whatever. It's worth watching. Then there's a project called Browser Time. It's a part of the SiteSpeed IO project we saw before. Browser Time are the parts of the SiteSpeed IO project that execute code in the browser. And as you can see, from the second from the bottom, they also include the RAM speed index JavaScript. And these scripts here are very easy to read. They are mostly not more than a page, and they extract metrics from these API we saw. One thing's a little bit sad. There is Boomerang.js, there are these browser time things, but there is no out-of-the-box RAM solution that is open source. So something like browser time, which is a perfect thing to set up, spin up a Docker container, and run it into your own infrastructure. I haven't come across a good RAM measurement solution that is open source. Maybe you know one, then maybe you can raise your hand at the end. If you have interest on working on one, I am also interested on working on one, but yes, I don't know of one. Tips. One thing that is very important, knowing how to measure and what to measure is important, but the most important thing is keep measuring and act on the things you've measured. So the concept Tim Cadillac came up with is performance budget. So you sit together with the product team, with your product manager and everyone, and you define, okay, I want my product page never to be more heavy than 1 megabyte of JavaScript, for example. Or we want to have a page speed, a speed index, for example, that is always lower than 2000. And this is a more social thing. You have to define values, and then there are a lot of tools who break your build if one of these values gets violated, for example. And then you can act. You have a starting point for a discussion where you can discuss, okay, does this teaser have to be this huge? Can we make an optimization here? Can some things on the page be lazy loaded, for example, or can we remove another feature if we add a new one? Adding things to your integration pipeline, I've talked about it before, and visualizing your stuff, having a dashboard showing the numbers, your current values is quite important. Facebook did a really interesting thing. Maybe they're doing it or they are still doing it. They wrote a blog post on this 2 years ago where they have Google 2G Tuesdays. So on Tuesday, every developer gets a pop-up in their Facebook app which asks them if they want to drop to 2G speed for 2 hours from now. It's an opt-in thing, but it was introduced company-wide, and to raise awareness of not all people have campus speed Wi-Fi's, and yes, there are things that you have to think about your application in a slow environment. And the most important thing is show, don't tell. So two of the things I've shown record videos. Web page test is very great at also rendering comparison videos. It's pretty easy. You enter 4 URLs and then you select these test results in the user interface, and it generates another video which does a side-by-side comparison of all of them. So if you're now looking, we have Hagebau, Obi, Hornbach, and Turmbaumarkt, and we are viewing how the source get displayed on their page. And if you show a customer this comparison, it doesn't have to be 4 video comparison, a 2 video comparison with the biggest competitor. Most times it's sufficient. I've included the 4 video thing because I came across Turmbaumarkt and it didn't stop loading, but it wasn't, yeah. After 30 seconds, it stopped loading. Then I drilled deeper into the results. You see the speed index visualizations. The Turm thing starts at 23 seconds, and if you view the megabyte overview, you see why, because they don't use JPEG for product images, but they use PNGs and they use huge PNGs. So, thanks for your talk. This is all the videos I've tried while creating this talk. If you're interested, talk to me, follow me on Twitter. If you're interested in working on this stuff, we are building e-commerce solutions, and we're always looking for work. Thank you.